We're going to solve this time for initial velocity using the physics equation Vf squared equals Vi squared plus 2AD. First thing we want to do is move this term to the other side. Since this term is being added, we're going to undo it by subtraction. So we can subtract 2AD from both sides of our equation. We end up with Vf squared minus 2AD equals Vi squared. It might appear that we're finished, but we're not, because we're not solving for Vi squared, we're solving for Vi. So we have to take the square root of both sides. Initial velocity is equal to the square root of Vf squared minus 2AD. Now, let's check our units to make sure that we end up with the units we're supposed to end up with. Because if we don't, we've got to go back to the drawing board. We've made some kind of mistake. So to check our units, we're going to use dimensional analysis. I'm just going to rearrange some things here to make it a little easier to see. Now, initial velocity is going to be measured in meters per second. So whatever we have under here, we need to make sure that we end up with those units meters per second. I'm just checking units, so I'm not going to add any numbers. Final velocity is measured in meters per second. Acceleration, meters per second squared, and distance in meters. So this term would end up being meters squared over seconds squared. I'm not paying attention to my numbers, so I really don't care about that too. I'm just looking at my units to see if I've done it correctly. Meters times meters would give me a meter squared over seconds squared. Now I'm going to be able to subtract because these both have the same units. So underneath my sign, whatever you call this sign for square root, you've got meters squared over seconds squared. Now if you take the square root of that, you end up with meters per second. So sure enough, we have solved our equation correctly.